Doody-doody-doody-doo-doo. Hey, look, I have mail. Good thing I have my handy knife. Let's see what it is. What's in here? A dial-a-rom for a Model 100. Wow. Isn't it pretty and shiny? I'll have to plug this right into my Model 100 and try it out. Here is my Model 100. I will pop open this cover and set my dial-a-rom to F for freaking awesome, or TS-DOS. It plugs right in. I will put the cover back on and turn the memory battery on. Now, following these handy directions, I will enable TS-DOS. Look, TS-DOS. I happen to have my backpack handy. I will plug it in. And turn it on. And then we will view the disk contents. Looky there. Let's go into the test directory. What? Disk not ready? Why, computer gods, why? Thanks to PCBWay for sponsoring this episode. They offer an excellent quick-turn PCB prototyping service, which now has a free upgrade to the 150-160 temperature range. They also offer a wide range of services that allow you to go from idea to a finished product, including CNC machining, 3D printing, injection molding, PCB assembly. Go on over to PCBWay.com/OEM to find out more. Well, it went something like that anyhow. This video is about the cause of this error and the 40-year-old Radio Shack technical bulletin that tells us how to solve it. So let's jump right in. To help demonstrate this problem a little more clearly, I have our Model 100 set up here. The serial port is going through a breakout box that has the backpack connected to it. I've got a couple wires here which are going to ground, and pin 20, which is the DTR output. It's one of the handshaking signals. And I will bring the meter in here so we can see the voltage on that pin. You might already notice that it is about minus 2.6 volts, and for an RS-232 communication, that's kind of low. Generally, we see the voltage swing in between, let's say, minus 12 and plus 12 down to minus 5 to plus 5. This is already pretty sketchy. If we go into TS-DOS, okay, I'm going to hit F4 here to show the disk directory. Notice we're at minus 2.67 volts here. So it does bring up the initial directory and then drops or raises to 1.7 volts. What is happening here is that it's turning on that DTR signal, and that should raise to 5 volts or greater actually, and it's only 1.7 volts. And we're kind of measuring in the middle of the loop, which I'll explain here in a little bit. So the actual voltage getting to the receiver of the chip inside the machine is much lower than that. When I first saw this, I thought there was a bad chip in here. That RS-232 voltage level shifter chip is a common failure on these guys. and I did a lot of measurements comparing this 100 to a Model 102, and you notice I saw the voltage dropping down as low as 0.8 volts. This was at the receiver pin of the chip, and I compared it to the 102, who was, you know, close to 5 volts or over 5 volts. And I thought, okay, it's definite that the chip in here is bad, and I swapped the chip out, and it did the very same thing. Let's take a look at the schematic of the RS-232 circuitry for this Model 100, and we'll see where the problem lies, and then we'll look at the technical bulletin from Radio Shack that was released in 1983, 40 years ago, that tells us how to fix it. So here is just the RS-232 driver and receiver circuitry on the Model 100. And what we see here is we have 3 outputs and 3 inputs. So we have transmit and 2 handshaking signals, receive, and the complementary handshaking signals. They are going through small capacitors and a resistor. The resistor is a current limiting resistor. The capacitor is some type of filtering they put in there. And it's sort of the same on the receiver side. We've got a resistor divider network in here. But what we're concerned about for this presentation is this transmit side. Of course, you know, the transmit and receive lines are kind of self-explanatory. These handshaking lines are basically used so that the computer can say, hey, are you there? And the device can say yes, and the computer can say, hey, are you ready to send more data? And the device can say, yes, I'm ready for that data. That's the basic idea. Now, the device you're talking to can actively toggle these signals based on what it's ready to do or not. And it's also very common just to loop them back. And that just lets the computer know that the device is connected. Now, in the normal configuration for talking to the Model 100, the backpack loops back DTR to DSR. And when TS-DOS goes to communicate with the disk drive, the TPDD2, it sets DTR and it expects to see DSR set in return, and then it knows the disk drive's there and it's ready to go. The backpack kind of eavesdrops on that signal to wake itself up, so it can sit there turned off most of the time until TS-DOS is ready to talk to it, and it'll turn itself back on. This should work out just fine, but it doesn't. And I spent all sorts of time coming up with this set of tests here, and I really thought this chip was bad. And I replaced the chip, and it didn't help. And I scratched my head, and then I actually did some math and looked at the size of these resistors. We have a 5.6K resistor on the output and a 6.2K on the input. That means we are dropping a lot of the voltage that these transmitters are putting out by the time it gets back to the receiver. In fact, it's so low here that it just barely works in a loopback mode, and it's rather low in general. It's not a very good design. I think at the time when I was testing this, I put another resistor in parallel with these signals, and that allowed it to work. And I was like, wow, I wonder why they designed it this way. It doesn't make any sense. Other people had Model 100s and they didn't have this problem, and I was confused as to why. And then a friend of mine said, hey, I have these TRS-80 technical bulletins for the portable computers. Would you like a copy? And I said, sure. So he's nice enough to send me a PDF he scanned. These are really high quality PDFs. And I sent this to my friend that designed the backpack, and he said, like, well, hey, well, the first one for the Model 100 describes that problem you had with yours, with the RS-232. And I haven't even read them that closely yet. And I pulled this out, and I was like, well, I'll be darned, it does. So what they're describing here is replacing those 4.6K resistors in the output with 330 ohm for precisely this problem. It talks about different Radio Shack devices that the Model 100 couldn't communicate with back in the day, which prompted this change. And if we compare this Model 100 RS-232 circuit with the 102, which I had zero problems with, we can see they already have the 330 ohm resistors in here, and they doubled up the drivers for the outputs. So they learned their lesson from the Model 100, and they really beefed up the RS-232. Now, some people have had an awful lot of problems with the serial output on the Model 100, and I am guessing a lot of it had to do with these really weak drivers because of these 3 resistors. Now, as it happens, I have hundreds of 330 ohm resistors. I don't know why I've accumulated so many over the years, but I do have them. This should be a relatively simple swap to put them in there, so let's take care of that right now. So the 3 resistors in question are this first one here on the left, and then the one on either ends between these 2 capacitors. So I marked one of the leads on each of them there, and then flipped it around and did the same thing here. Now, of course, these leads have been crimped over as part of the insertion process. So here's our 3 resistors. I marked them with a black dash between the legs. These legs are kind of bent over like this as part of the insertion process. That keeps them from popping out as they go down the line. So I took the soldering iron, put under the leg, heated it up, and just carefully bent it up. And now I'm going to add a little more solder to each of these. This will make it a little easier to desolder, and it helps to preheat the joint. Now we'll use the desoldering tool to free those from the board. That lead was caught in there. You notice I'm letting that pad heat up about 3 seconds. You want to make sure you get the solder melted all the way through the board. If not, it'll be hard to remove the part and you'll likely rip a trace. And when I'm wiggling the iron, I'm not pressing down, I'm just rotating it. Goodness, that was like sticking in that tip. That means they should come out rather easy. One of them's already out. They were like, we've been in here 40 years longer than we should have. We're not the right resistors. Please replace us. There. Oh, come on, guys. There we go. Okay. I've got 3 new resistors here, which I've probably had at least 35 years. I've got one of those little resistor leg forming things that I 3D printed, but I will just do these by sight. There we go. And just fold your legs over. And I like making sure all the colored bands match. It doesn't really make any difference, but it looks nicer. If somebody looks at your rework later, they'll know that you took pride in your work. Now, if I already soldered these in there and they didn't match, I wouldn't take it back apart. But as long as I'm thinking about it ahead of time, I'll take the time to make them match. Oops. Mr. Capacitor there was hiding R94. There we go. And my furnace is kicking on. Okay, now we'll just solder these guys back in. I'm going to tack one leg on each of them. And those are all nice against the board. I'm happy with that. Yep. Those are seated well. Okay. We'll solder the other leg. Again, I'm leaving the iron on there about 3 seconds to make sure I'm heating the whole joint up completely. Okay, now we'll clip these legs off. And I'll go ahead and I'll clean up my solder joints with a little alcohol and a Q-tip. We'll reassemble this enough to test it, and we'll see how it worked. Before buttoning this back up, I did want to point out a couple changes in case you saw them. This is that driver chip I'd already replaced, which I didn't need to replace. And you'll notice I don't have the NiCad or nickel metal hydride memory backup battery in here. I used a super capacitor on this one. This works fine. It doesn't last nearly as long as the NiCad or nickel metal hydride, but it was kind of fun to do. But for all my other ones, I've just used the battery. I actually glued this in a little too far that way, and it blocks access to that screw, which is kind of a pain. Okay, now let's test this thing. Okie doke, I got this computer buttoned up. I reinstalled TS-DOS, and we're just at the prompt where TS-DOS has appeared. And you'll notice right away we've got minus 4.4 volts instead of just over minus 3.3 volts. So we're already better off. And again, where we're measuring is right here at this loop back. So we've swapped out this resistor and we're measuring right here. We've gained a volt there, and if we fire up TS-DOS, there we go. And we're still at 4.4 volts, and we tell it we want to look at the disk. And it is hovering and staying at plus 4.5 volts. Remember, before that was only coming up to 1.7 volts, and that was causing our problem. So now, I know it's hard for you to see the screen, I'm going to go into directory test01, and that works fine. I can, oops, wrong button, load a program, F1 load, load as, same name. That worked fine. I can go back up to the root directory, and I want to look at RAM, and there is the program we just loaded. Everybody's favorite test program. Oops, F8. I'm going to go back to the main display, and we will run hey2.ba, which just prints Hey Birt down the screen. Jeff from the future here. After recording this video, a friend of mine said, hey, I have the same problem with my NEC 8201a. So I checked mine, and sure enough, it had exactly the same problem, and it had exactly the same resistors as the Model 100, which makes sense as these came out roughly at the same time and were both made by Kyocera. So here's where the resistors are, and I replaced them in the same way, and the results were the same. It now works great. Well, how about that? That was a nice simple fix for the serial port on our Model 100 here. I did want to point out that they do include a serial number cut-in that requires this modification. Of course, we know this one did because we measured it directly. I did double check the serial number, and it is below the number listed here, so it did indeed need the modification. So I will put a link to all of these PDFs in the description down below, so you can download those and have them in your collection. This is a very easy mod. If you've got one of these Model 100s, it's an easy thing to do. Just need 3 resistors, and your serial port will be a little better. If you have any questions or comments, I sure would love to hear from you. Just leave them in that comment section that's down there below. Thanks to everyone who helps support the Hey Birt channel through Patreon and other means. It is greatly appreciated. Well, until next time, bye.